Hi, welcome back to my second video on energy. The first one we talked about energy stores and we mentioned that energy is stored in objects. It can be transferred also. So this is really the idea about energy moving from one place to another, or actually being used, because another thing we talked about in the last video was the fact that energy can be used to do things. Now, an energy transfer explains how that energy is being used to do something. So the first kind of thing we need to talk about is what energy transfers are, and we've already said this. So when things happen, energy gets transferred. So it's moved from one place to another, or it's changed from one type of energy or one store of energy to another. So this idea about energy transfer, it just means when energy is moved from one place to another or one type to another. If something happens, energy transfer will have taken place. Energy will have changed. So an example, quickly, me again going up the stairs, start off with I had one type of energy at the bottom of the stairs. When I get to the top of the stairs, there is a different type of energy there. Now, the new GCSEs try and make things a little bit more complicated, because we talk about things called energy pathways, and an energy pathway actually causes the energy to be moved from one place to another. It's the actual process that causes the energy to be changed from one type of energy into another. So if you get the energy transfers taking place, there will be a pathway there as well. So an example, so we'll just go through a few examples of what the energy pathways are. We've got chemical reactions. So a chemical reaction can cause energy to be changed from one type of energy to another. An electrical current, again, will transfer energy from one place to another. Thermal conduction transfers energy from one place to another. We'll talk about that more in a later video. Forces clearly cause energy to be transferred, as do EM waves. Now, EM waves you probably haven't done yet, but an electromagnetic wave, an example would be light. So we've talked on the last video about the fact that light isn't an energy store because you can't store it, but light does cause energy to be moved from one place to another. So an example is a light bulb in a torch, for example. The torch uses a battery, it's got energy stored in the torch. When you switch the torch on, light is transferred from the torch to the surroundings. Now I'm going to get rid of these two, because to try and go through some examples to let you know what I'm talking about, I'll run out of space if I keep them up. So I'll keep the energy types up there, and we'll go for a quick example. So first example, lifting a ball up, keeping it simple. So bit of a description to start off with. A person uses their muscles, obviously, to lift up a ball into the air. That's the situation. They picked up a ball, they're holding it in the air. Now, talking about the energy stores there, at the beginning, there's chemical energy in that person's muscles. When the person lifts the ball up in the air, they take that chemical energy and they turn it into a different type of energy. That's what happens when the ball is lifted up. Now, obviously, the ball's been lifted into the air, so it's now got gravitational potential energy. So we've talked about the energy stores. At the beginning, we start off with chemical energy, and at the end, we have gravitational potential energy. And we can see that in this energy transfer diagram. So we've got this box to show the beginning point, which is obviously at the start. There's a chemical store in this person's muscles, and then we have another box to show what type of energy we have at the end. So in this case, it's gravitational energy that's stored in the ball. So energy store 1, energy store 2. Now something has happened in between that to cause this energy to be transferred into this energy. Now we know, just from my little story, that what happened was the person used their muscles to lift the ball up in the air. From physics, a physics point of view, there is a chemical reaction. Chemical reactions take place in the person's muscles, and that takes that chemical energy and it allows it to be transferred into the ball. If you wanted to go into even more detail, you could mention forces, because obviously to lift the ball up, the person would have to use a force. But I've just gone with a chemical reaction. So recapping, trying to keep this as simple as possible because it can get very difficult, very detailed. To start off with, there was a chemical store in the person's muscles. They lifted the ball up, And that energy that started off in the muscles is now in the ball, but it's stored as gravitational potential energy. What happened to cause that change was a chemical reaction. The chemical reaction took place and it caused the energy to be transferred from chemical into gravitational energy. So this is an example of an energy transfer diagram, and you see plenty of these in the exam. They miss things out, so they'll say a person's lifted a ball up in the air, complete the energy transfer diagram, and you'll have this, you'll probably have that, and they'll ask you to write in the type of energy that is now in the ball. They might ask you to draw one from scratch, so you just need to remember, in the box you write down what your chemical store is, in the second box you write down what your new energy store is, and in the middle you write down what the pathway was. So another example, carrying on from the lifting the ball up, they're obviously going to drop the ball now. Now a bit of the description again. The start, there's gravitational energy stored in the ball because the ball's up in the air. The person lets go of the ball and the ball starts to move. If it starts to move, it gets kinetic energy. Now, it's got that kinetic energy from somewhere else. You can't just magic energy into existence. So it must have come from somewhere. In this case, obviously, it's come from the gravitational energy in the ball. So, energy transfer diagram. We've got first box. This is the starting point. You've got gravitational potential energy stored in the ball. The second box, the ball's moving. And that's therefore got kinetic energy in the ball. What has caused the gravitational energy to be transferred into kinetic? Well, it's a force. It's the force of gravity. Gravity has pulled on the ball and caused it to move. So once again, we've got a starting point. This is the starting energy. We've got an ending point. This is the ending energy. And we've got the pathway that has caused the energy to be transferred from one to another. So think for your own examples. Imagine walking up the stairs. What would be the energy pathway there? What type of energy, when I started walking, was stored in my muscles? What type of energy did I have when I was at the top of the stairs? What pathway caused me to do that? Obviously, it's pretty similar to the ball example at the start. Same types of energies involved. Thinking about a calculator. You've got an energy store perhaps in the batteries, which is chemical. You've got chemical reactions. You've also got an electrical current, which takes that energy and transfers it around the calculator. Again, these can be fairly simple, straightforward examples like the one you've just seen there, or you can get it into a much more detail. Now, the ones you see in the exams will be pretty straightforward. It will be quite clear to most people what type of energy is stored at the start and what type of energy is stored at the end and what has happened in between.